So it's funny when you asked me to do this, I was like, well, how can you summarize what's going on in AWS Link? Because there's so much. If you subscribe to, they have a blog where they post announcements, and there's like 5 or 6 posts a day, and it's just relentless. This is what AWS does. So I really wanted to think about, if you pay attention, I tend to, even though I work for an AWS partner and I have to be focused on Amazon pretty heavily, I basically really find myself on like almost a monthly or quarterly cadence where I'll go in and dive in and really understand, what are the major things that have shifted that I wasn't tracking, carefully before. And so that's kind of what I've done here, and just wanted to show around 3 key categories. And this is one slide, okay? So, and all the information isn't in the slide, but these are just some high level things since kind of Q4 2019 that have happened that I think are particularly interesting. And the 3 categories that I wanted to talk about are cost optimization, the evolution of serverless, which is a kind of a hot topic and one that's near and dear to my heart, and kind of containers and progress with containers. So on the cost optimization front, there's kind of 2 things that I think are worth talking about. Anyone who uses Amazon, one of the things that our customers are constantly talking to us about is like, we're terrified that our bill is going to go way up, right? Because it's a self-service environment, right? The customer can go in, they can spin up whatever they want. And it's sort of the double-edged sword of cloud is, on the one hand, it's highly agile, it's really easy to provision infrastructure, and you pay for what you use as you go. On the downside, anyone can do it. And if you're not paying close attention, you might end up having a bill that spikes by, 30, 50, 70% in a matter of a month. And so there's a couple different mechanisms that are in place that have helped with this. So the first is there's something called Compute Optimizer for EC2 that was announced. And I think this came out at reInvent or just before or just after. So one of the biggest costs that most customers in AWS have, and really in any public cloud, is compute, right? Especially kind of the more traditional compute, which is virtual machines. And what we've discovered when we go through customer environments trying to help them save money, when you instrument their environments, there's so much money that can be saved with right sizing and being like, hey, you way over provisioned this VM. Like, part of the purpose of cloud is to pick the smallest instance size that's going to do the job, right? And you have one that's 3 times too large, and you're shedding money. So Compute Optimizer actually is a ML-driven service from Amazon that will analyze your environment and help and give recommendations on how you can save money. And this is cool because the reason I wanted to call this out is not because it's particularly interesting. Like, it's not all that sexy, right? Even though it has ML in the name, right? And it is using, most machine learning branded things are really just like heuristics as a service, which is basically what this is doing. But it's pretty smart. And the thing that I think is particularly interesting about it is it's from the cloud vendor saying, here's how you be more efficient and save money, which is, I like to call this out to people. People assume that AWS is all about like, we got to get people to spend more money. And the answer to that is yes, over time, but they're really long in their view of it, right? They do things like this because they want people to be happy and then be like, oh, that's working really well on AWS. I want to put my other workload on AWS, right? So you can call it customer obsession, but I think the reality of the situation is it's really about just playing the long game, right? And that's to all of our benefit. So if you're using EC2 heavily, Compute Optimizer is a good little like toggle it on and get some recommendations kind of tool. So the second thing I want to talk about is a much more sophisticated thing, which is called savings plans. Now this is, CTOs, we generally own the bill, right, for infrastructure. And the funny thing about the way you save money in AWS, there's all sorts of technology ways to do it, but there's also like these kind of financial mechanisms that they give you. So the most popular mechanism for saving money on compute is reserved instances, right? And a reserved instance, if you're not familiar with how it works, basically you go in and you make a commit on a term. So it's either 1 year or 3 years. And based upon the length of that commitment, you get a discount on that compute. Now, there are also financial mechanisms for how much money you put up front, right? So on that commit, if you put down all of the money up front, you save the most money. If you put no money up front, you save the least money, right? And then there's other mechanisms as well, like convertible reserved instances and all this stuff. The most important thing here is that a reserved instance isn't actually an instance, right? It's a financial thing that you are committing to on your bill. And then as you spin up instances, and destroy them, you're drawing down from that reserved, kind of financial mechanism. So it's a billing thing. So I'm talking to a bunch of technologists about a billing thing. And I know that's not sexy or exciting, but it's really important because you own the bill, right? At the end of the day, you're the one who's going to get told, reduce our infrastructure costs, right? So RIs are complicated and hard, right? And it's good for me as a business. We're an AWS partner. We manage RIs for a bunch of customers, and that's great because they're getting savings and we're getting money and everyone's happy. But Amazon has noticed that there's a whole bunch of people who just aren't doing it, right? Because they don't have time. They're too busy. And so they introduced this thing called savings plans. So it's a fully automated, more hands-off mechanism that's separate from RIs. And it has some benefits over RIs. So first of all, it supports things like Fargate and cross-region coverage, which you can't really do with reserved instances. And basically, there's a couple different kinds. There's a compute savings plan and an EC2 savings plan. And they're basically spend commitments. So you say, I'm going to make a long-term commit for $1 per hour. And if I do that kind of $1 per hour rate commit, I'm getting a lower rate on my compute. And the two different kinds, CSPs, compute savings plans, and EC2 savings plans, the CSPs are more flexible, but they don't give you the best discounts, right? So if you go a little bit farther with the EC2 savings plans, you have to do things like pick a specific instance family type and set of regions. And so it's less flexible, but putting just a little more effort, you get more savings, okay? So one of the common questions I hear from people about savings plans is like, oh, should I just not do RIs? And the answer is no. They're different things. There's benefits and kind of trade-offs. It's just another tool in your tool belt, right? RIs have some intrinsic value. So when you commit to an RI and you buy it, you can actually, if it's not a convertible RI, you can take that RI and you can put it in what's called the marketplace, and you can sell it to somebody else. So you can say, I committed, $23,000 in compute, right? And I need to shed that, right? My something has gone sideways and I need to get, free up that capital. You can go to the marketplace and sell it, usually at a loss, but usually not at that much of a loss. And you can recoup your costs, right? You cannot do that with savings plans. Your commits are your commits are your commits with savings plans. And if you do buy convertible RIs, you can do things like exchanges. So you can say, I have a compute, an instance that I'm buying that is a commitment on an RI that's convertible, but it's starting as, this exact instance type and family. You can go back and say, I would like to change that commit now to be a different one. And you're not getting penalized because that's part of what a convertible RI is. So I'll shut up for a second because I just regurgitated a whole bunch of information about how to save money. But these are all financial mechanisms and it takes a lot of effort. So the nice thing about savings plans, if you're not doing anything today, you can turn them on and start saving some money.
In the flurry of getting your system up and running and sort of that fear of commitment because you're scaling up and down, it's really, you're not doing it right if you aren't then settling on reserved instances. Is that correct?
Yes. And what we like to tell people is when they engage with us and say, hey, look, I'm spending too much money, we want to get them to 90% plus coverage in terms of optimization. And that means that 90% of their compute is covered by reservations. And for some workload types, that's actually not possible because they're very spiky and maybe they don't lend themselves well to that. And then we look at mechanisms like spot instances and so on. But honestly, the vast majority of workloads out there that I encounter are relatively, stable, or at least a significant portion of it is the baseline is there, right? And reserve that. If you don't reserve that, you're leaving 40, 50, 60% savings on the table, which is bonkers. So it takes a lot of work and effort, which is good for me and my company, but it's worth it, right?
Seems like a low-hanging fruit for auditing your expenses.
Absolutely.
I did not know that there was a marketplace for getting rid of your RIs.
Yep.
Evan, just briefly, any comments on RIs as far as it relates to Terraform?
I never use them enough as I should. That's my first answer. Yeah, I mean, I think that you can provision them because I had to go back in and double check, but you, and Jonathan, you correct me if I'm wrong here, you buy them into a pool, and then you basically, when you go provision them, they provision out of your RI pool. Is that correct?
Essentially, right?
Yeah.
You can kind of think of it as you put the RIs in at your payer account, and then any linked accounts that are actually where you have usage, that usage just happens. And then when it's consolidating the bill at the end of the month, it first pulls from your reservations.
Gotcha. Yeah.
Yeah. And as you said, it's not a virtual difference between an RI and
they're separate things. You buy commitments, and it's a financial mechanism that's reconciled, and then you have your EC2 activity that you're doing behind the scenes, and marrying those, they're literally unrelated. Like, you're not going to get a situation where you try to spin up an instance, it's like, oh, I'm sorry, or spin down one, it's like, I'm sorry, this is reserved. You're not going to get that.
I thought that they deployed the RIs in like the section of the bad memory chips. So I wonder if
they put you all on machines that are vulnerable to all of the Intel bugs. That's right.
The old machines. It's so funny how the brain works. So I love that. So thinking through it as really just a financial costing exercise and nothing different to the actual quality of the instance.
Yeah. One thing that I'll say is, so Terraform Cloud and Enterprise, when we launched cost estimation last year, and I don't believe it will take into account that kind of, like, if you have RI credits or RIs within your account, because it's looking at basically like, okay, you spun up an instance of this size, therefore I'm going to tell you that the cost estimation of this run is this dollars. Yeah. I don't think that there is a whole thing that we went through about trying to figure out if Amazon's API that gives you costs for things will basically like look at account specific discounts, which RIs are sort of similar to that. And I think that, I can't remember where we came down on that, but that's, if anyone out there ends up using the cost estimation inside there, that's just sort of something to keep in mind. So it is an estimation, and not, it will cost, it's not a checker at the checkout line, right? It's definitely an estimate. So
there are some very specialized tools out there that make it much easier. Like, you can use the Cost Explorer and some of the tools that are in the console to kind of guide you down the path of buying reservations, but it's not great. So there's some really good specialized tools out there, like Cloud Health is a great example. It's a CMP platform. They just got bought by VMware, sadly, but they're still a great company and an awesome platform. We're actually partnered with them, and you can, add that tool to your account, and it goes through and really can give you good recommendations. It's what we use internally to do recommendations for our customers. Okay, so I'm going to shut up about cost now, because I'm talking to a bunch of technologists about money stuff, and it's not sexy, but it is important. And I put it first because I thought if I put it at the end, all your eyes would be already glazed over. So now we'll talk about service to get us all excited again. So I am personally like all in on serverless, right? I'm a big believer in kind of the future of how we interact with infrastructure and how we interact with our applications being deployed into the cloud is serverless and serverless-based kind of services. I do hate the term serverless, but it is what it is, and we can't change it. So three big important things that happened in the last kind of 6 months or so. So the first is something called provision concurrency. So for those of you who aren't familiar with AWS Lambda, it's a serverless execution environment for your application code. So you can write code in a variety of different runtimes and programming languages, and you can then deploy that directly to AWS, and it fully manages the execution environment. You have no control over it. You don't really care about the operating system necessarily. You don't care about really any of the packages installed. You build things in an isolated little way, and you deploy it to AWS, and boom, there it is. You can those Lambda functions can then be executed based upon a variety of different events, including if you're building out like a microservices application, you can create like APIs using the API gateway, and those can actually call into Lambdas. So anyway, Lambda is really cool and really great. One of the big challenges is you don't control the execution environment. And with EC2, you can do things like scaling up and out, and you can control that. And you have mechanisms using things like auto scaling to kind of facilitate that scaling. With Lambda, it's massively scalable out of your control, right? Meaning you deploy this function and you can call it 1,000,000 times concurrently if you want to, right? And AWS will manage automatically deploying that code, which under the hood is actually a little container, and provisioning it out to their execution environment and scaling it up and then scaling it down again. But there is a issue called cold starts, which is a common kind of problem across pretty much all of the serverless kind of function environments out there. And a cold start is it manifests itself as a pause or a delay in the execution of a function. And so you call the function, which normally takes, let's say it takes 1/10 of a second to run and return code or return a response. And then all of a sudden you call it, it takes 3 seconds. That's weird. Maybe it even takes 4 or 5 seconds. Well, what's happening is as you're scaling up and out and traffic is increasing, AWS is opportunistically having to copy your function, that container, out to other compute nodes in order to provide the capacity to actually respond, right? And it doesn't know what traffic is going to look like, right? It has no idea, and it has no mechanism for you to really understand that. So that cold start is a delay as the functions are starting to be copied out. Now, AWS has done a pretty good job of minimizing this impact and effect, but with provision concurrency, which is a feature that was just recently announced, you can have more control over how many copies of your Lambda function are available at any given time. And there's kind of 2 ways to do it. One is you can do it kind of statically, and you could say like, I am willing to pay for 500 pre-warmed instances, like ready to execute at any given time. So it's sort of like a reservation, right? Like I'm going to preserve this amount of available capacity. If it goes above and beyond that, I'm willing to deal with cold starts. The other thing you can do is you can actually use auto scaling, application auto scaling. And you can use a scaling policy called Lambda Provision Concurrency Utilization. And it's a predefined metric within AWS. And you can tie the provision capacity, the number of warmed instances or warmed copies of your function, to the utilization of the provision capacity. So what you can basically say is like, I would like there always to be 80% of my provision capacity there, and 20% used, right? And 20%, extra capacity just in case, right? And you're paying for that, but that way it's like pre-warming in advance as things, start to get exhausted. So if you have these spikes, you can effectively eliminate cold starts if you dial things just so. So that's provision concurrency. It's super cool. There's great documentation on the AWS site about it. And I think it's an exciting thing because it allows you to get around the biggest kind of bugaboo with serverless performance. This is all about performance, right? A year or 2 ago, it was actually pretty difficult to use SQL databases from Lambda. And the reason for that is because you have no control over the execution environment, as I said. And you could end up spinning up thousands of containers, and each one of those containers, if it needs to talk to your database, would spawn a new connection. And so if you get the traffic spikes, you don't have any sort of connection pooling or any sort of like intelligence there. And so you could literally like knock over your RDS database, or your SQL database that you're self-managing, instantly, right? If there was a spike in traffic. This was a problem, right? So for the longest time, it was just like, oh, just use Dynamo, right? It's like, cool, but like, I don't want to use Dynamo. I like my SQL, right? Or I have a Postgres application. I need to use my data store. So the cool thing is they did make an improvement, kind of late last year, where they actually took the connection handling for RDS from Lambda. They moved it out of Lambda and into a proxy layer. And that proxy layer is doing connection pooling to make sure you're not going to overrun connections on your backend. So many people took a look at serverless a year or two ago and were like, I can't use it with my SQL database because I'll knock it over. And now you can, right? Provided you're using RDS, because AWS has more control over the environment. If you're self-managing your SQL server, first of all, don't do that, right? There are reasons that you might need to, but generally speaking, if you don't have one, you shouldn't be. And then, adopt RDS and you're good to go. RDS is Amazon's fully managed database service. And so for years, I've been running MySQL and Postgres for a long, long time. I'm older than I look. And when you are managing a MySQL database yourself, you have DBAs, you have system administrators, you have the execution environment that it's running in, so maybe an EC2 instance or a physical server or whatever you happen to have, and you have to like monitor it, manage it, reconfigure it, scale it up, scale it down, and that sucks. Like that, I mean, that's the literal explanation of why you shouldn't do that is because it sucks to do it, right? It's not fun. You're gaining no value. Generally speaking, you have like really smart, very capable engineers, and you're telling them to babysit your MySQL server. That's just a waste of time.
And is it just briefly? Okay, I get it. So you're meaning instead of installing or managing your own database apps, you just use RDS.
Just use
is replication just 2 seconds? Is read slaves and replication all obfuscated, or is it just easier to do in those environments?
All available. They expose quite a lot to you. The way to think of it is instead of going in and editing config files and from MySQL and editing operating system settings and setting up replication manually, what they've done is they've instrumented everything around MySQL, all of that standard stuff, and Postgres and Oracle and blah, 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 blah. They've instrumented all of that with APIs. And all of those APIs are available in wonderful things like Terraform. So you can go in and you can say, I would like to provision, a MySQL RDS cluster with 2 read replicas, whatever it is that you want to do, you can do that. And you can scale them up, you can scale them down. You have all of the control you need. The nice thing about it is you're not having to babysit it, right? Because once you've configured it as such, AWS is responsible for making sure that those configurations get pushed correctly and that they work and that the execution environment is up and available. So, those smart people can instead be focused on things like optimizing the underlying SQL that you're using, or, doing schema changes to improve performance, or adding indexes, or whatever it happens to be, instead of like tinkering with the configuration of MySQL. Still having their heads like, oh, I can't use Lambda because cold starts. Well, now you've got provision concurrency. I can't connect to my SQL database. Now you can with the RDS proxy. And the third is, I've heard there's problems with VPC networking. And there were, and now there aren't. And that is the TLDR on that, right? AWS has made a change now to VPC networking for Lambda. And they rolled out starting in September of last year, and they basically finished rolling it out kind of globally late last year, I think in like December. It was end of November. And it basically eliminated a lot of these latency issues. So that's it on that. It's not exciting. It's mostly just a if you last time you checked, these things were obstacles for you, they shouldn't be obstacles anymore. There hasn't been a lot of change in containers on AWS over the last quarter, okay? The only major one that I think is useful to talk about is for people who are interested in using the Elastic Kubernetes service. So if you're a heavy user of Kubernetes and you wanted to use AWS's managed Kubernetes service, you still had a lot of management you had to do. You had to control and configure the EC2 environment that kind of backed, your Kubernetes clusters. Now you can actually run Kubernetes nodes on Fargate, which is AWS's kind of quote unquote serverless, environment for containers. And that's nice because it reduces the management burden further, which I'm a big believer in. Like, a lot of times people will say, like, I don't think it's that big a deal for me to self-manage something. It's worked for me up until now. It's like, that's great. but you're going to hit something where it won't work for you one day. And then you're going to be spending an inordinate amount of time doing what AWS calls undifferentiated heavy lifting, right? There's no reason to do that work when someone else can do it for you for effectively no cost or a very small cost, right? And redeploy your smart people to do other value creating things. That's kind of the idea. So that's EKS for Fargate. If you are running containers on Amazon, you can use two different flavors of container orchestration. There's ECS, which is their Elastic Container Service, and there's EKS, which is their Elastic Kubernetes Service. And these services are effectively handling a lot of the orchestration of, I have a bunch of containers I want to deploy, I want to deploy some microservices, and kind of scaling up and scaling out and all that good stuff. ECS is AWS's that came out before Kubernetes did. And then EKS is their market entrant because they know that a bunch of people are excited about Kubernetes.
Got it.
In the past, you could run containers under two launch modes on ECS. One launch mode was EC2 backed, and that means that you have control over, I would like to pick this EC2 instance size, type, whatever, and you had to configure the environment, right? And say, I think based upon the shape and size of my workload that this is going to work best. And you had to manage it, and it's effort, it's work. Fargate execution is, AWS, please handle that for me, right? Mm-hmm. You decide which compute nodes to provision, when to provision them, in much the same way that Lambda, automatically provisions the underlying compute in the background. Fargate, outsources the provisioning and management of the compute nodes for your containers to AWS. And you used to only be able to use it with ECS, and now you can also use it